Question number 14. You are given a set here with these 5 members and one binary operation asterisk is defined in this way: a star b equals to a plus b if their addition is less than 6, and a star b equals to a plus b minus 6 if their addition is 6 or more than 6. First we show that 0 is identity, so you need to show a asterisk 0 equals to a, and similarly 0 asterisk a equals to also a. Now a asterisk 0, here it would be a plus 0 only, because a plus 0 is less than 6, this condition, because a comes from 0 to 5, so any member from 0 to 5 plus 0 is always less than 6, so a plus 0 is a asterisk 0 is a plus 0, and which is a. Now come to this 0 plus a. Here this case a asterisk b is a plus b if their addition is less than 6. What is 0 plus a? 0 plus a is again less than 6. Why? Because a is any member from the set A. So maximum a is 5. So 5 plus 0 is 5. So it is always less than 6. So it is a. And this is true for every a in A, remember. So what you have shown, a asterisk 0 equals to 0 asterisk a equals to a. And therefore identity equals to 0. E equals to 0 is proved. Now next we show that inverse of a is 6 minus a. We want to show this. So what is need to show? This asterisk this is identity. If you remember, a asterisk a inverse should be identity, and reverse, a inverse asterisk a should be again identity. This is the meaning of inverse, you know it. So I'll start with a asterisk 6 minus a. Now if I add this 2, then a will get cancelled, so summation is 6. So a plus 6 minus a, what's the sum of these two? 6. So if summation is 6 or more than 6, then you need to do minus 6. So we'll write minus 6 here. What's the reason? If you want, because of this here, a plus 6 minus a equals to 6, and which is greater than or equal to 6, you can say. This case, second case we are using. I repeat, why I wrote minus 6? Because here second case is applicable. Here the first case was applicable. You check the sum of these two. A asterisk b, a plus b I have checked. So sum of these two, this plus this. If I write this plus this, what is your answer? It is 6. So answer is 6 or more than 6, then you need to do minus 6. So that's why we wrote this. And 6 will get cancelled, a will get cancelled. So this is 0, which is identity. Now I'll do reverse. 6 minus a asterisk a. Again you add these two. 6 minus a plus a. Sum of these two is 6. So if the summation is 6 or more than 6, then you need to do minus 6. So I'll write minus 6. Reason, because your 6 minus a plus a is 6 is greater than or equal to 6. I'm emphasizing that here second case is applicable, remember. So 6 will get cancelled, a will get cancelled. This is 0. So what you have shown, a asterisk b is 0, b asterisk a is 0. So therefore you can say that inverse of a is 6 minus a. It's proved. Question number 15. You are given two functions f and g from a to b. Their domain of the function is functions f and g is this. Formula for function f is this. Formula for function is this. Right. The question is see whether these two functions are equal or not. Are f equals to g? This is the question. Now you recall from 11th standard. Recall two functions f and g are said to be equal if fx equals to gx for every member of the domain, for every x in the domain. I repeat, two functions f and g are said to be equal if their values are equal for every member of the domain. So that's what we do here. Here how many members are there in the domain? 4 members. So we find f of minus 1. You can just prepare the table here. You can write set A, which is domain here. You can have fx here and you can have gx here. First member, let's take minus 1. I'll find f of minus 1. What is f of minus 1? Minus 1 square plus 1. So this is 0. Oh, sorry, this is 2. I'm sorry, this is 2. Find g of minus 1. So 2 into minus 1 by 2 minus 1. So this is 3 by 2. 2 will get cancelled. This is also 2. Both are equal. Similarly go for 0. So here 0 minus 0, which is 0. Here 2 into 0 minus 1 by 2 minus 1. This is also 0. And so on. You will notice that for every member, that is for 1, 2, this is same as this. This is same as this. So you can say that fx equals to gx for every x in A, and therefore f equals to g. They are equal functions here. Next question is, you are given a set here. Find the number of relations are containing this two-ordered pair, which is reflexive, symmetric, but not transitive. So I'll try to construct a relation here R, which should be reflexive. So all three ordered pairs should be there: 1, 1, 2, 2, and 3, 3. This guarantee that it is reflexive. 1 related to 1, 2 related to 2, 3 related to 3. Containing these two. So I need to put 1, 2, and 1, 3. Now I want symmetric, remember. So if I put 1, 2, I need to put 2, 1. If I put 1, 3, I need to put 3, 1. So now reverse of each ordered pair is present, so it's a symmetric. But you see that this is not transitive. Why it is not transitive? For example, you can take 3, 1, 3 related to 1, and 1 related to 2, but you see that 3, 2 is not there. If I put 3, 2 here, it becomes transitive. Even you can see that 2, 1 is there, 1, 3 is also there, but you can see that 2, 3 is not there. So therefore it's not transitive, and this is the only possibility. If I put this 2, then if I put this or this ordered pair 3, 2 or 2, 3, it becomes transitive. So I cannot put this 2. And you know A cross A would have all 9 ordered pairs, 3 plus 5 plus 7. So now I cannot put any ordered pair. So this is the required relation, and is the only relation. Is the only relation. You cannot form any other relation which is reflexive, symmetric, but not transitive. So only one relation can be formed. Only one relation. Only one relation. So here correct option is A, remember. Now question number 17, next MCQ. You again have a set 1, 2, 3 consisting 3 members. You want equivalence relation. Equivalence relation means it should be reflexive, symmetric, and transitive, all 3 properties, containing 1, 2. So let's try to do this. Here I'll take a relation, I want reflexive. So I'll take 1, 1, 2, 2, 3, 3. This guarantee that it's reflexive. Containing 1, comma 2. So if I put 1, comma 2, I must put 2, comma 1 because I want symmetric. Now let me check whether it is transitive or not. You can see if I take 2, 2 and 2, 1. If I drop this common, 2, 1 is itself. If I take 1, 2 and 2, 1, if I drop common, 1, 1 is there. So this is transitive also. So this is reflexive, symmetric and transitive. So this is equivalence relation. This is equivalence relation. One more. Of course you want reflexive. So I need to put 1, 1, 2, 2 and 3, 3. I need 1, 2 also containing 1, 2. So I'll put 1, 2. Then I need to put 2, 1 also. This is same. Now further, suppose I'll put here you may have 2, comma 3. From A cross A, what we have in our mind is A cross A, remember, if you go back to relation. If I put 2, 3, I need to put 3, 2. Now here this is if I keep up to this much, then you can see that 3, 2 is there, 2, 1 is there, but 3, 1 is not there. So if I keep this much, this is not transitive, so I need to put 3, 1. Now if I put 3, 1, to make it symmetric, I need to put 1, 3 also. So indirectly you can see that this is just A cross A, entire A cross A indirectly, all 9 ordered pairs, and which is always equivalence relation. Remember, this is always equivalence, and these are the only 2 relations. So total number of relations is 2 here. So B is correct option. One is this, the other one is this one. I'll emphasize, probably you might have confusion. Up to this you are fine, but why I placed 2, 3? Because up to this it was the previous relation. Now if I add 2, 3 to make it symmetric, I need to add 3, 2. Now if I keep up to this one, it will not be transitive, because you see I have 3, 2, I have 2, 1. So 3, 1 must be there, but 3, 1 is not there. So I place 3, 1. If I put 3, 1 to make it symmetric, I need to put 1, 3. That's why this is the entire A cross A. So one is this and second one is this. So there are such 2 equivalence relations. So correct option is B. Next MCQ, you are given the signum function, you know very well. Greater than 0 then 1, 0 then 0, negative then -1. It takes these 3 values. And the other one is a standard box function. That is this one. Now question is, are these 2 functions equal in this domain 0 to 1, that is f of g equals to g of f? That's the question. So we find the composition, open 0 to closed 1, and we'll try to see this. So I'll try to find f of g first. So here f of g at x equals to f of gx. Now g is box function. Now here from open 0 to, if I take values from open interval 0 to 1, then gx will be 0 box function. So this is 0. On this gx is 0. So that is one possibility. On this, value of the box function is 0. You take any number 0.1, 0.2 up to open interval 0, 1, then the box function takes 0 value. So here 0. So what is box of 0? It is 0. Now which number is left out here? If now 1, x is 1, then g of x will be 1, because box of 1 is 1. So in this case here, f of 1, and what is box of 1? It is 1. So we have 2 possibilities here. Which 2 possibilities? If x is on open interval 0 to 1, then the value of the box function is 0. You know it from 11th standard. And what is the f of 0? If x is 0, then the value of the function is 0. Here, now you are left with integer 1. Then box of 1 is 1. So again, if I come back to 1, this is f of 1. This is another case. This is one case. This is the second case. And what is the f of 1? This is positive number. If x is greater than 0, then box value is 1. So these are the two possibilities for FOG. FOG at x is 0 on this interval. And FOG, if x is 1, then it is 1. Okay. I'll go to RHS now. RHS now. If I go to right hand side, GOF at x. So it is g of fx. Now here you are talking about in this domain only. So on 0 to close 1, here x is always positive. Positive, then you have fx equals to 1 only. Now what is g of 1? That is a box of 1. This is 1. So you see here g of takes always value 1. Here FOG may take 0 and 1. So are they equal? No. So FOG is not equals to GOF on open 0 to closed 1. I repeat one more time. Here only you need to see carefully. If you have open interval 0 to 1, then the value of the box function is always 0. You know it. Gx means box. So I have placed 0 here. What is f of 0? Look at here, it is 0. If x is exactly 1, close interval 1 means 1 is there. Then g of x is 1. What is f of 1? It is 1. So LHS takes two values, 0 and 1. 0 and here 1. Go to RHS, right hand side, GOF. Their domain is open 0 to closed 1. So this is always positive. If it is positive, then the value of the function is always 1. So g of 1. Now what is the box of 1? It is 1. So RHS always take value 1. Here you may have 0 and 1. So therefore these two are not equal. Next 90 number, you have set with two members. You are asked for number of binary operations. Now recall what is the binary operation? Is a function from A cross A to A. So number of binary operations equals to number of functions from A cross A to A. Now if you remember from permutation, number of functions is given by number of elements in A, which is 2, raised to number of elements in A cross A, which is 4 here. So you have here 2 raised to 4, which is 16. Number of elements in A raised to number of elements in A cross A, which is 4. So therefore there are 16 binary operations. Remember here, this is a general formula. You can remember number of elements is given by number of elements in this raised to number of elements in this. Remember, in general this is a formula. In general, number of binary operations, general number of binary operations is given by equals to n raised to n square. You see here n is 2, so here 2 raised to 2 square, so it is 2 raised to 4, which is 16.